Tonight, let's drift gently into a story that feels both impossible and strangely tender. A story whispered in the silence between stars, wrapped in starlight, and carried to us through the quiet eyes of the James Webb Space Telescope. Welcome back to Fall Asleep to Science, where the universe softens into something close to a lullaby and even the strangest discoveries arrive with calm, shimmering wonder. As you settle in, maybe lying down or resting your weight against something soft, allow your breathing to slow. Let it move like a tide, gentle, steady, unhurried. With each breath, the noise of the day loosens, and the night becomes a little deeper, a little wider, a little kinder. Tonight we follow a visitor, not a star, not a planet, not even a comet, in the usual sense, but something older, something quieter, something drifting toward us, from a place we may never see. Scientists call it 3I Atlas, an interstellar traveler that slipped into our solar system with the calm certainty of a falling snowflake. For a while, it looked like a strange but natural wanderer, an icy fragment from another star. But then James Webb pointed its deep, patient gaze toward it, and something changed. Many of the scientists watching the data unfold felt their breath pause, not in fear, but in awe. There was something in the readings, something warm, something patterned, something almost rhythmic, that made even the most experienced researchers lean a little closer. Tonight we will explore this story gently, slowly, without rushing toward conclusions, and without stirring alarm. You are safe here. This is a place for wonder, not worry. Some scientists believe that 3I Atlas carries unusual warmth inside its frozen shell, warmth arranged in patterns that seem almost like metabolic breath. Others see hints of structure across its surface, subtle shapes that repeat, shimmer, and shift with the light of our Sunday. And a few, including Michio Kaku, have spoken softly about the possibility that something inside the visitor might not be entirely inert, not alive in the way forests breathe, and not alive in the way oceans move, but perhaps alive in a way we have never imagined, alive like a slow, ancient rhythm, alive like a distant heartbeat, made of minerals, ice, and chemistry, older than stars. But tonight is not about fear or speculation. It is about listening quietly to the universe as it whispers. Take a slow breath, feel your body settle, and imagine James Webb floating far beyond the moon with its mirrors turned toward this mysterious traveler. Its instruments cooled to a temperature near absolute stillness detect faint colors and delicate heat. It listens to the light that 3I Atlas reflects. It listens to the heat the object breathes out. It listens to the subtle oscillations in brightness, like a lullaby sung in wavelengths we cannot see. Scientists believe that every object in space tells a story. Some stories are simple rocks, circling stars, dust swirling in clouds, planets spinning quietly for eons. But the story of 3I Atlas feels older, as if it carries memories from a time before our sun was born. Its dust seems shaped by pressures foreign to our world. Its glow seems sculpted by stars we have never seen, and its warmth, soft pulsing, almost shy, suggests it may have layers within layers, like a seashell grown in a faraway ocean. Imagine drifting alongside it now, floating in the deep dark, where sound cannot travel. You see the object turning slowly, its surface glittering under faint sunlight. You see thin lines of vapor leaving its body like delicate silver threads. But these threads do not swirl or twist. They stretch straight outward, steady and calm, as if the object is breathing in long, quiet exhalations. Some scientists think these lines might reflect internal chambers, ancient tunnels shaped by cold, by pressure, by time. Others think they might be guided by pockets of warmth moving through the interior, warmth that flows in repeating rhythms. And some, looking at the quiet pulse of heat mapped by James Webb, whisper that something about these patterns feels intentional, not in a frightening way, not in a dramatic way, but in the gentle, ordered way that living things often shape their own boundaries. Take a slow breath and let that possibility float through your thoughts without weight. This is a place for imagination, for calm curiosity, not for certainty. Tonight's journey will be about those small hints, the faint patterns, the quiet anomalies, the soft pulse of heat that made Michio Kaku stop mid-sentence and lean closer to the screen. We will explore how scientists read those signals, how they listen for rhythms in starlight, how they search not for fear but for understanding. And through this exploration, you may feel your own breath slow, your body grow heavier, your mind drift toward a place where wonder becomes rest. Because the truth is gentle, the universe is full of mysteries, but most of them are quiet. Most of them drift. Most of them glow softly like lanterns floating on a cosmic sea. 3i Atlas is one of those lanterns. And tonight, we follow its light. Take one more breath. Slow, warm, peaceful, and allow the night to wrap around you as we begin this long, soothing journey through the strange, beautiful story of what James Webb found inside an interstellar traveler. Let your breath settle again, slow, soft, and effortless, as though your body already understands that this part of the journey will be even gentler than the last. When James Webb first turned its golden mirrors toward 3i Atlas, scientists expected to see something familiar. A cold traveler, a drifting shard of ancient ice, a quiet fragment from a star system far beyond our own. But the light that returned to Webb's instruments carried a subtle difference. Not a warning, not a shock, just a whisper of something unexpected, like hearing a faint melody behind a closed door. It is believed that the earliest clue was a pattern in the reflected light. Not bright, not dramatic, but strangely regular. Light pulsed from the object in a rhythm too smooth to be dismissed as noise. The pulses were so soft that even computers hesitated, uncertain whether they were reading a signal or the faint flicker of cosmic dust. Scientists watched quietly, their faces calm and thoughtful, as the data repeated. One cycle, then another, then a third, just as gentle, just as steady. Take a slow breath and imagine those pulses moving like tiny heartbeats across the darkness. This rhythm intrigued them, but it was not enough to draw conclusions. Rhythms can emerge in natural processes, heat dispersing ice, fracturing dust, settling into ordered layers. But then came the second clue. A faint glow, not caused by heat, and not caused by sunlight. Webb saw a soft shimmer emerging from beneath the surface, a glow that brightened and dimmed in its own slow pattern. Some scientists whispered that it resembled bioluminescence, not the bright flash of fireflies, but the deep, dreamy glow of creatures living far below Earth's oceans, where sunlight never reaches. Imagine that for a moment, a soft, living light, born in the darkest waters of the sea. And now imagine something similar, glowing inside an interstellar traveler. Take another breath. Feel the calmness of that image settle. This glow did not behave like reflected light. It did not change with angle. It did not scatter. It came from within, moving through the outer layers like a breath-warming thin ice. Some researchers suspected chemical reactions. Others thought of minerals that emit light when stressed by heat or pressure. Still others considered that this glow might hint at processes we have not yet understood. Processes that, in the calm language of science, could be called biochemical-like. No declarations were made, only quiet curiosity. Then came the third clue, this time from heat. James Webb mapped the surface, using its sensitive infrared eyes, and what it saw felt like an ancient world stirring in its sleep. The warmth inside 3I Atlas did not spread randomly. It flowed through channels thin and meandering like streams cutting through stone. These channels connected regions that warmed together, cooled together, responded together. Patterns like these are rare in inert objects. Heat usually spreads evenly unless some structure, some system guides it. Scientists believe that these pathways may be remnants of ancient cracks in the ice or tunnels formed long ago by gentle cycles of freezing and thawing. But there was something almost rhythmic in the way the warmth traveled, as though responding to an internal logic. Take a soft breath and imagine heat moving like a warm tide through a frozen landscape. After seeing these early signs, scientists turned to spectroscopic analysis, a gentle way of listening to the chemical voice of an object. Webb can separate light into delicate ribbons of color, each ribbon revealing a different molecule, a different fragment of the object's story. Here, 2-3I Atlas whispered something unexpected. Its surface held organic compounds, simple ones, nothing alarming, perhaps nothing more than the building blocks formed in the cold between stars. But some of these molecules showed a slight preference for one-handedness over another. Scientists call this chirality, and on Earth life chooses one direction, almost universally. This preference was faint, not enough to make claims, but enough to deepen curiosity. Because in nature, handedness rarely emerges without a reason. Take another breath. Let your thoughts drift like dust through sunlight. As James Webb continued to observe it, captured one more gentle anomaly, a faint alignment of surface patterns that looked almost like geometry. Not rigid, not perfect, not technological, just slightly more ordered than the chaotic mosaics found on typical comets. Some scientists believe that repeated cycles of sublimation could carve such shapes. Others suggest that fine-grained minerals could align under long-term radiation. But a few, speaking softly, wondered whether something inside might be shaping its own environment in subtle, ancient ways. Nothing conclusive, nothing frightening, just quiet questions drifting through quiet rooms late at night. Take a slow breath and allow the wonder to rest gently. Through all of this, Michio Kaku watched the data with a calm fascination. He spoke not of fear, but of possibility. He reminded us that alive does not need to mean what we think it means. That life could be slow, mineral, non-biological, or something entirely new, a pattern of warmth, a rhythm of light, a gentle pulse of chemistry that takes centuries to complete a single cycle. And if such a process exists inside 3I Atlas, James Webb may have been the first instrument to witness it. As these early clues unfolded, the world grew quiet with anticipation, not in alarm, but in awe, because even the faintest possibility of something slowly, softly alive inside an interstellar visitor makes the universe feel a little closer, a little warmer, a little more connected. Take one last breath for this section. Slow, deep, peaceful. The story is only beginning, and 3I Atlas still holds many quiet secrets. Let your breathing soften again, as though each inhale drifts in from a faraway star, and each exhale glides back into the quiet of space. We're stepping deeper now into the gentle mystery of 3I Atlas, not with urgency, not with fear, but with the calm curiosity that science inspires when the night is still. After the first subtle clues, the rhythmic pulses, the soft internal glow, the flowing warmth, James Webb continued to observe with the patience of a silent guardian, and slowly, almost reluctantly, the object revealed more. Scientists began to notice a pattern in the glow itself. It brightened and dimmed in a sequence so soft so delicate that early computer models dismissed it as ordinary scattering. But the repetition persisted, and when the pattern was stretched over many hours, a gentle rhythm appeared, not perfectly even, not mechanical, but unmistakably intentional in its consistency. Take a slow breath and imagine a lantern flickering in a slow, thoughtful way, as if adjusting to the breeze around it. The glow seemed to originate beneath the surface, not from sunlight, not from heat, but from something within. And what made scientists pause was that the glow shifted in harmony with the object's rotation. It grew brighter when certain regions turned toward the sun, not because they received more light, but because the internal glow responded to that light in a calm, delayed whisper. This gentle delay suggested a process, something within the object, absorbing energy, holding it for a moment, and releasing it slowly through faint luminescence. Some scientists suggested chemical luminescence similar to reactions in ancient ocean life on Earth. But the conditions were too cold for most known reactions. Others proposed minerals that glow when stressed by temperature changes, a phenomenon seen in rare stones found deep beneath Earth's crust. Take another breath. Picture those glowing minerals, their faint light shimmering in underground caverns where silence reigns. Yet the glow of 3I, Atlas, was gentler than any mineral known. It was rhythmic, softly responsive, almost sensitive. Researchers mapped the glow with Webb's precision instruments and discovered a surprising fact. It followed a path, not a random path, not a chaotic scattering, but a flowing curve traced across the object's interior, like a river of dim starlight. This curve connected warmer regions to cooler ones, moving through channels that seemed to predate the object's arrival in our solar system. These channels guided the glow in a way that resembled circulation. Not blood, not life, but an ancient system for transporting heat or energy from one region to another. Scientists believe that such channels could form over millions of years through cycles of freezing, fracturing, and pressure from distant starlight. But the harmony of the glow moving at the same pace through each channel raised gentle questions. Some wondered if the object had internal layers that exchanged heat like a slow mineral-based metabolism. Others thought that the glow reflected tiny vibrations through crystal-like ice, a kind of crystalline respiration. Nothing certain, only possibilities. Take a slow breath and let those possibilities drift. The next detail came from observing how the glow reacted to solar particles. Most icy objects brighten when struck by solar wind as charged particles collide with dust and ice. But 3I Atlas did something different. Its glow dimmed. Not dramatically, not suddenly, but softly, as if the object were shielding itself. This dimming did not spread across the whole surface. It concentrated in patches, each patch positioned where earlier heat maps had shown gentle thermal pulses. It is believed that these patches might act like ancient regulators, absorbing energy and releasing it slowly to protect internal structures. On Earth, certain rocks and minerals can buffer heat in this way, preventing sharp spikes from damaging their form. But the harmony between heat flow and glow patterns in 3I Atlas felt too coordinated to be dismissed easily. Take another slow breath and imagine a frozen world quietly adjusting to external warmth. As James Webb continued its observations, scientists noticed one more detail. A soft twist in the polarization of the light leaving the object. Polarization refers to the direction in which light waves vibrate. Dust from comets usually creates random polarization, scattering light chaotically. But 3I Atlas produced a delicate twist, subtle but real, as if the light had passed through an organized structure. Some scientists whispered that biological molecules on Earth twist light in similar ways because of their handedness. But no one claimed such a connection here. The resemblance was gentle, ambiguous, intriguing, but not decisive. Yet it added to the growing mosaic of patterns: glow, heat, rhythm, polarization, channels, flow, each one small, Each one gentle, each one easy to explain alone. But together, they formed a lullaby of quiet anomalies, soft, calm, and somehow beautiful. Take a slow breath and let the pieces settle in your mind like stardust falling upon a still pond. Through all of this, scientists stayed steady, careful, and calm. They used soft language. It is possible. It is thought. There may be, because certainty is never the goal of early discovery. Wonder is. Michio Kaku, when speaking about these patterns, did not shout or warn. He spoke softly about the possibility of new forms of organization, forms that move so slowly they resemble geology, yet behave with a rhythm that hints at something more deliberate. He suggested that life elsewhere may be mineral icy, slow, quiet, and older than imagined. And if 3I Atlas carries any echo of such processes, it would mark not fear, but a gentle widening of what we consider possible. As this section draws to a close, let your breath fall deeper, calmer, as though you too are aligning with the slow glow inside an ancient traveler. 3I Atlas continues to drift, and its soft patterns will soon reveal even more. Let your breathing fall into a slow, natural rhythm, the kind of rhythm the body remembers on its own when the night is quiet and the mind begins to drift. We are traveling deeper now into the soft mysteries of 3I Atlas, and each step reveals another layer of calm, ancient strangeness. After studying the glow, scientists turned their attention to the gentle movements of heat flowing through the visitor's interior. Heat in the vacuum of space usually spreads in simple ways through conduction, through sunlight, through the faint churning of sublimating ice. But inside 3I Atlas, the heat moved differently. Not chaotically, not randomly, but along narrow paths as though guided by hidden architecture. James Webb's infrared sensors picked up these movements with exquisite sensitivity, capturing the way warmth rose in small waves that traveled through the object like a slow internal tide. Take a gentle breath and imagine warmth moving under frozen layers, soft and patient, like breath under a sleeping chest. This flow of warmth seemed to rise and fall with surprising regularity. Scientists watched the cycle repeat, not quickly, not with urgency, but steadily, as though some internal rhythm were pacing the exchange. Some researchers compared it to geothermal pulses seen in icy moons, though those pulses are driven by tidal forces, not by sunlight. But here the pulses responded to the angle of the sun and the object's slow rotation. It was as though 3I Atlas felt the sunlight moving across its surface and adjusted its warmth in reply. The adjustment wasn't strong, it wasn't dramatic, but it was unmistakably coordinated. Take a slow breath and imagine a frost-covered organism shifting gently when touched by light. To understand this behavior, scientists modeled the internal structure using all available data density maps, thermal readings, and the faint glowing channels already observed earlier. The models suggested that the interior was not uniform. It had pockets of denser material, regions of porous ice, and tunnels that connected the warmest parts to the coldest ones. Some believed these features were carved naturally through billions of years of freezing and drifting. Others thought they resembled conduits, pathways, shaped to distribute warmth more evenly. Nothing conclusive, only gentle patterns. The most intriguing detail was the way the heat behaved when the object crossed a region of stronger solar wind. Instead of warming abruptly from the increased energy, the internal channels absorbed and redistributed the heat in a way that smoothed out the spike, like a buffer protecting the deeper layers. Scientists have seen similar behavior in certain minerals that release heat slowly after absorbing it. But the timing here was softer, more rhythmic, more deliberate. Take another breath and let your mind picture sunlight touching an icy traveler, and the traveler responding with a calm internal sigh. Then came another, subtle observation. Tiny plumes of gas escaped from the surface at intervals that matched the internal heat pulses. These plumes were not forceful. They did not twist the object or create visible jets. They were barely noticeable, like the faintest exhalations escaping through thin cracks. But they were synchronized. Every gentle release occurred just after a wave of warmth reached the surface. This suggested a slow, steady exchange between interior chambers and the frozen exterior. Some scientists whispered that it resembled a primitive form of respiration. Not biological, not living in the usual sense, but a system that takes in warmth and releases pressure through a repeating cycle. Others suggested the object might have pockets of volatile materials that warm and expand in predictable rhythms. A natural process, beautiful in its own way. But the synchronization with inner heat flow was difficult to ignore. Take a slow breath and imagine a world-sized stone breathing once every few hours. As Webb continued its observations, it detected something else, subtle expansions and contractions across the surface. These movements were incredibly small. Too small to be seen visually, but detectable through shifts in shadows and variations in infrared reflection. The surface would swell by tiny increments as warmth traveled upward and contract again as heat slipped away into deeper channels. This expansion did not fracture the surface as random heating normally would. It moved smoothly, evenly, like a body accustomed to such cycles. Scientists compared it to crystalline structures that flex under temperature, changes structures that can shift without breaking, because they are organized on a microscopic level. Some wondered whether 3I Atlas contained large regions of semi-crystalline ice, capable of flexing gently in response to internal warmth. Others suggested the presence of minerals known to store and release heat in slow, controlled patterns. The science was calm. The possibilities were many. But together these behaviors painted a picture of something ancient and quietly complex. Take another gentle breath and feel the calmness of such slow movements. The final detail of this phase came when Webb observed a slight shift in the object's rotation. Most interstellar visitors tumble unpredictably, but 3I Atlas adjusted its rotation in small, graceful increments that matched the timing of its heat pulses and surface expansions. These adjustments were not signs of control in the dramatic sense. They were drift-like, organic, the way a buoy turns softly in a warm tide. Scientists believed that internal heat might be redistributing mass just enough to nudge the rotation into a balanced state. Not intentional, not guided, just a natural dance between warmth and motion. But the harmony between these systems, heat, glow, rotation, and those faint plumes, was what caught Michio Kaku's attention. He said softly that even without life, the object moved with the quiet logic of a system that had organized itself far beyond randomness. It was a whisper, not a shout, a mystery, not a warning, a rhythm, not a revelation. Take one more breath, deep, slow grounding. Feel your body relax as the warmth of 3I Atlas continues its slow journey outward. The visitor's story is still unfolding, and the next layer may be the most delicate yet. Let your breath fall into a slow, gentle cadence, a soft in and out rhythm that feels almost like floating. This next part of the journey invites you deeper into the interior world of 3I Atlas, a place where silence carries patterns and ancient ice holds memories that may be older than our sun itself. After studying the heat that pulsed through the object's body, scientists turned towards something far more delicate, the faint structures hidden just beneath the frozen crust. James Webb, with its quiet sensitivity to reflected light, began picking up subtle variations in how different regions of the object scattered photons. These variations were so small that most telescopes would have dismissed them as noise. But Webb, patient and precise, saw a quiet order emerging. It began with tiny hexagonal patterns, not perfect, not polished, but repeating often enough to suggest intention in the way ice and dust had settled. Take a slow breath and imagine frost forming on glass, growing outward in crystalline arms that echo a hidden geometry. Scientists believe that under intense cosmic radiation, water molecules can reorganize themselves into repeating structures that mirror some forms of symmetry. Such patterns have been observed in certain types of laboratory-formed ice shaped under unusual temperatures and pressures. But the scale of these patterns on 3I Atlas felt different. They weren't small. They weren't isolated. They stretched across regions large enough for Webb to detect them from millions of miles away. Some scientists proposed that these formations were natural-born from long cycles of heating and cooling as the object drifted through the galaxy. Others observed that the patterns aligned with the thermal channels mapped earlier, as though the internal flow of heat encouraged certain shapes to form consistently. And then there were the ones who spoke more softly, suggesting that the patterns resembled the skeletal lattice of certain silicate-based organisms theoretically proposed to exist on cold worlds. Not life, not organisms, but frameworks capable of supporting slow, almost geological metabolism. Take another breath and let that idea rest gently, without weight or urgency. James Webb continued scanning, and as it did, it caught a glimpse of something even stranger. At certain angles, light reflected off the surface with a faint polarization, a twisting of the light wave that hinted at organized layers stacked beneath the ice. Polarization is a subtle thing. On Earth, it often comes from ordered structures, crystals, shells, or long organic chains with repeating orientation. In space, chaos is far more common. Rough surfaces scatter light randomly. Dust sends photons spinning in all directions. But 3I Atlas did not scatter light randomly. In certain regions, the light twisted, as if passing through layers that shared a common alignment. Scientists studied this carefully, comparing the data to all known crystalline signatures. They found similarities, but nothing that matched perfectly. The light seemed to be twisting in a way that hinted at complexity. Not complexity of construction, but complexity of structure. The kind that emerges slowly, patiently, over millions of years as minerals reorganize in response to subtle forces. One researcher described it as the geometry of a thought made of ice. Another said it reminded her of coral reefs, not in shape, but in how the shapes seem to follow deep ancient rules. Take a soft breath and imagine ice that has been thinking for a very long time. As scientists traced the patterns from one region to another, they noticed that the structures aligned with the faint channels of heat mapped earlier. Where warmth flowed steadily, the patterns became more pronounced, as if responding to the temperature cycles by reorganizing into tighter forms. This interplay between heat and structure created a soft, beautiful harmony, a kind of internal architecture that seemed to guide the object's behavior. And then something unexpected happened. During one of Webb's long exposures, the patterns shifted, not rapidly, not dramatically, but enough that the reflected light changed ever so slightly. The shift followed one of the object's thermal pulses, the same pulses observed earlier, moving through internal channels like breath. The surface shimmered with a gentle rearrangement, as if certain regions expanded or contracted in sync with the warmth beneath. Some scientists suggested that the ice was flexing as heat passed through it. Others wondered whether the crystalline structures were actively remodeling themselves to release stress, the way certain minerals on Earth rearrange under pressure. but a few whispered that this resembled the slow, deliberate behavior of materials that adapt to maintain equilibrium. Take another breath and picture a frozen landscape that shifts in harmony with ancient internal rhythms. Then came a new discovery, one that deepened the quiet wonder surrounding the visitor. In several regions, Webb detected what appeared to be branching structures embedded just beneath the surface. These branches spread outward from the warmest interior pathways, forming webs of delicate lines that reflected light with unusual efficiency. Scientists believe these patterns might be fracture networks formed by repetitive heating, or they could be mineral veins grown through slow crystallization over billions of years. But again, the harmony was strange. The branches did not spread randomly. They followed curves, intersections, and arcs that reflected the same slow rhythms seen in the object's heat pulses. It was as though the interior architecture guided each new line, each new fracture, each new mineral vein, in a way that maintained the overall balance of the system. And this balance seemed almost adaptive, not in the sense of intention or decision, but in the quiet, natural way that certain systems, from coral reefs to crystal growth to ancient cave formations, organize themselves to preserve stability. Take another slow breath and imagine a frozen cathedral carved by time itself, its arches rising from patterns older than memory. The more Webb observed, the more it felt as though every part of 3I Atlas was connected. The glow, the heat, the structure, the rhythm, not alive, not mechanical, but something in between. A system with patience, a body with cycles, a form that carries echoes of distant suns and forgotten worlds. And somewhere inside it, James Webb saw the faintest hint of movement, too slow to be called motion, too deliberate to be chance. Take one last breath. Deep, soft grounding. We are only beginning to understand the quiet order within this ancient traveler. Let your breath ease into something even softer now. A quiet rhythm, a gentle tide. As we move deeper into the mystery of 3I Atlas, you might notice the patterns, forming patterns in the glow, patterns in the heat, patterns in the structure beneath the ice. All of them slow, all of them ancient, all of them strangely harmonious. But there was one pattern that James Webb detected, which caused scientists to fall silent, even in rooms filled with soft conversation and steady instruments. A pulse, not a dramatic pulse, not a flash of light, not a burst of energy, just a tiny rhythmic shift in the wavelengths returning from the object's surface. It repeated itself again and again in a period so gentle that instruments nearly missed it. Imagine something glowing barely brighter every few minutes, so faintly that the glow is more like a whisper than a signal. Webb captured it first in the near-infrared bands, a soft oscillation that moved across the object's surface like a ripple through moonlit water. Take a slow breath and imagine that ripple passing through silence. At first, scientists thought it was simply the effect of sunlight flickering across rotating terrain. But the pulse did not match the rotation. It did not match solar wind activity. It did not match any known thermal behavior in interstellar objects. It was too regular, too patient, too precise in its repeating calm. Some scientists described it as the quietest heartbeat ever recorded in the universe. Others said it resembled the slow oscillations seen in certain chemical systems that breathe in cycles of reaction and rest, taking hours or days to complete a single loop. The pulse inside 3I Atlas moved through the object like that, a slow wave of slightly increased brightness, followed by an equally soft dimming. It spread through the surface in branching arcs that mirrored the hidden structures mapped earlier by Webb. The branches lit up in the same order every time, not chaotically, not randomly, but in a sequence. Take a gentle breath and imagine a field of tiny lanterns lighting one by one, following a path etched into frozen earth. This sequence was so delicate that it took days to confirm it was real. Computers analyzed the data again and again, filtering out noise, correcting for cosmic interference, adjusting for the steady rotation of the visitor. And after the noise was removed, after the signals were aligned, after the data was examined in every imaginable way, the pulse remained. Scientists began to study how the warm channels mapped earlier intersected with the glowing patterns. What they saw was quietly astonishing. The pulse always began in the warmest region, a pocket deep inside where subtle thermal exchanges had previously shown the strongest rhythmic cycles. From there, the glow flowed outward through the branching structures like a soft electrical signal, moving through nerves. It is believed that the pulse might reflect the slow expansion and contraction of mineral veins as they absorb and release heat. But the timing was too gentle, too consistent to match known geological cycles. Another idea suggested that the pulse could be a photochemical reaction, a slow accumulation of trapped energy that releases when a threshold is reached, like a stone that glows faintly after being warmed by the sunday. But again, the harmony was puzzling. Each pulse seemed connected to the faint plumes seen earlier, those soft exhalations escaping through tiny cracks. Every time the glow rose, a subtle release occurred moments later, as if the object were letting out a slow breath. Take another breath yourself. Let it be soft. Let it be warm. Let it be steady. The more Webb observed, the clearer the pattern became. The pulse traveled at the same speed, every time passing through the same branches, lighting the same curves, reaching the same distant regions with perfect regularity. Some scientists whispered that it resembled peristalsis, not in a biological sense, but in the repeating wave-like movement of energy or material through a structured system. Others suggested that it might be a relaxation, oscillation, a type of natural cycle, common in chemical systems that operate far from equilibrium. Nothing definitive, nothing certain, only the quiet wonder of a rhythm that persisted. Then, after many days of continuous observation, a new subtlety emerged. The pulse changed, not dramatically, not violently, but slightly. Its timing shifted by less than a heartbeat's fraction in human terms. A shift so tiny that only the most sensitive algorithms could detect it. This shift occurred just after 3I Atlas passed behind the Sun from Webb's perspective, a period when direct observation was impossible. When it re-emerged, something inside it seemed to have adjusted. The warmest region was slightly warmer. The glow followed a slightly altered path. The pulse's starting point moved by a few degrees. Scientists believe that solar radiation during this hidden period may have warmed a deeper chamber within the object. Or perhaps the internal structure reshaped itself to better distribute heat. But a few, speaking softly and cautiously, wondered whether the pulse's shift reflected adaptation. Not conscious adaptation, not intelligent adaptation, but the same kind of gentle adjustment seen in certain crystal systems that rearrange to maintain stability. Take a slow breath and imagine the soft rearrangement of something ancient, responding to sunlight after millions of years in darkness. As the weeks passed, the pulse remained steady, predictable, almost soothing in its repetition. Some scientists began to refer to it quietly as the respiration cycle, not because it implied life, but because it captured the feeling of a system breathing at its own pace. Michio Kaku spoke of it with calm reverence, saying that the universe may hold forms of order that exist between life and non-life systems, that pulse, adapt, and respond on timescales far slower than humans can perceive. And 3I Atlas, with its gentle heartbeat of light, might be one of them. Take one last breath for this section. Deep, soft, peaceful. The ancient traveler still has more to reveal, and the next discovery will be its most enigmatic yet. Let your breath soften. Let your shoulders feel just a little heavier as as though gravity itself has become gentler. We are drifting now into a deeper layer of the strange, soothing mystery of 3I Atlas, a layer woven not from ice or heat, but from light itself. Because after the discovery of the pulse, after the quiet rhythms and gentle exhalations, James Webb detected something even more delicate, something so faint that it was first dismissed as an instrument artifact, a whisper, not a sound. Sound cannot travel in space, but a whisper in the light, a soft modulation that moved through certain wavelengths as though carrying information. Take a slow breath and imagine moonlight rippling, as if touched by an unseen hand. This modulation did not behave like reflection. It did not behave like scattering. It had structure, but structure so subtle that it took days of continuous observation for scientists to believe it was real. The whisper appeared in only one narrow band of near-infrared light, a region where organic molecules sometimes leave faint signatures. But the signature here was not a simple curve or a chemical fingerprint. It was a pattern that repeated, a pattern that shifted ever so slightly with each pulse of the object's internal rhythm. Scientists watched as peaks and valleys of light rose and fell in quiet harmonies, like a chord played on an instrument older than stars. Some researchers suggested that the pattern was a form of photoluminescence, certain molecules glowing in response to heat. Others thought it might be crystal lattice vibrations, interacting with infrared photons in complex ways. But a few whispered that the pattern had the same softness, the same rhythm as the quiet pulse detected earlier. Take another breath. Let the rhythm settle gently in your thoughts. The whisper was too faint to resemble communication, too calm to be mistaken for a beacon. But it carried order that unfolded in long, slow sequences that matched the ancient traveler's internal cycles. Webb's instruments captured the whisper in long exposures, revealing that it followed the same path as the thermal pulse, moving across the surface in a wave of slightly altered light. Each region glowed with a slightly different hue, as the modulation passed as though the light were being filtered through a shifting matrix. Scientists believe that this could be caused by layers of ice containing minerals that change reflectivity when warmed. Each layer might respond differently to the thermal pulse, creating a cascading effect that appears like a wave of color. And yet, the timing was too perfect. The pattern, too harmonious. A few researchers speaking quietly in late-night discussions suggested that the whisper could represent a primitive information cycle, not intentional, not communicative, but a byproduct of ancient chemical processes happening inside the object. A memory, perhaps, frozen long ago, reawakening softly under the warmth of our Sunday. Take a gentle breath and imagine light carrying the echo of something older than life itself. Then something happened that made the scientific teams pause completely. The modulation shifted in response to a change in sunlight. Not dramatically, not quickly, but after a slight delay. A delay that matched the time it took for the thermal pulse to travel through the interior. When the sun brightened slightly due to normal solar fluctuations, the internal glow of 3I Atlas responded first, and the whisper in the light followed. This sequence suggested that something inside absorbed the energy and released it in a controlled, rhythmic way. Nothing supernatural, nothing frightening, just a system reacting calmly to warming and cooling cycles. But then, the modulation shifted again, this time in a way that could not be explained by sunlight or rotation or thermal behavior. It shifted when the object passed through a region of stronger magnetic activity in the solar wind. Scientists have seen minerals respond to magnetic fields in crystalline arrays. Ice can align under long-term radiation. Dust can charge and discharge in subtle ways. But the whisper in the light did not simply intensify or fade. It changed shape, as though the structure through which the light passed had rearranged itself in response to the new environment. Take another slow breath and imagine the faint glow of a crystal reacting softly to the world around it. This rearrangement did not happen instantly. It unfolded gradually over several hours, a slow shifting of the pattern into a new stable form. Scientists who studied complex adaptive systems began to take notice, not because the object was alive, but because the whisper in the light behaved like a system seeking stability. Some compared it to convection cells forming in a pot of water. Others compared it to phase transitions in slowly heating solids. A few compared it to chemical waves that propagate through reaction networks far from equilibrium. And Michio Kaku, watching the data with quiet fascination, said softly that this might be a glimpse into the earliest stages of chemical organization, a form of matter, not yet alive, but not entirely inert, something between, something ancient, something patient. Take another breath. Let your mind feel the calm weight of that idea. As the whisper in the light continued its slow, dreamlike rhythm, James Webb detected one final detail. The modulation was not symmetrical. It rose a little faster than it fell. A slow inhale, a slower exhale, a rhythm that matched the faint exhalations of gas seen earlier. The light changed when the object breathed, not in a literal sense, but in the sense of internal cycles moving in harmony. Heat, glow, pulse, light. All four systems were beginning to reveal themselves as parts of a single ancient pattern. A pattern perhaps shaped in the cradle of a distant star system. A pattern that survived billions of years of drifting darkness. A pattern that only awakened when touched by the warmth of our Sunday. Take one last soft breath. Slow, calm, peaceful. The whisper is only the beginning. The next discovery will be even stranger. A movement that should not be possible for an object so old and so cold. Let your breath settle, soft, warm, unhurried, as we drift into one of the strangest, most delicate discoveries ever made about 3I Atlas. A discovery so subtle that even the scientists who witnessed it weren't sure what they were seeing at first. Not because it was frightening, but because it was impossibly gentle. Up to this point, 3I Atlas had shown signs of rhythm, of heat flow, of faint glowing channels, of whispers in the light. But all of these could be explained: slow chemical cycles, extreme crystalline behavior, mineral patterns shaped by time. Movement, however, movement is different. Objects in space tumble, they drift, they rotate with ancient momentum set in motion before Earth even formed. But they do not ever, adjust themselves in response to their surroundings. That is why the next observation left the scientific teams quiet for a very long time. James Webb noticed that the object's rotation was shifting not randomly, not chaotically, but smoothly and predictably, as though guided by an internal process rather than external forces. Take a slow breath and imagine watching a leaf floating on water, turning just slightly when touched by sunlight. The first sign was a tiny decrease in rotational wobble. Interstellar objects often tumble into complex spins after billions of years of collisions and gravitational nudges. But as 3I Atlas soaked in sunlight, the chaotic tumbling eased, slowed, softened into a more stable orientation. This is not unheard of. Sunlight can create pressure that smooths rotation gradually, but the timing here was too harmonious. The stabilization happened in sync with the thermal pulses moving through the interior, almost as if each pulse redistributed mass ever so slightly, nudging the rotation into alignment. Scientists believe that internal pockets of warming material could shift balance in a natural, gradual way, but the way this shift matched the pulse, the glow, the whisper in the light, made researchers sit quietly in their chairs, watching the data unfold with calm astonishment. Take another breath and feel the rhythm settling into your own body. The second sign was even softer. Tiny jets, barely noticeable, began to escape from cracks, aligned with the warmest interior regions. These jets were not dramatic. They didn't twist the object or create long tails. They were faint exhales that Webb detected only through minimal changes in infrared brightness. And these jets appeared precisely after the glow wave reached the surface. Not before, not during, after. As though the object were releasing pressure in a controlled, gentle sequence. This is common in sublimating comets. But the synchronization with internal cycles made it unusual. The jets were too faint to adjust rotation significantly, and yet rotation did adjust, always following the same internal timing. Scientists suggested that even tiny releases of gas from deep chambers could create micro-forces inside the object, pushing it into smoother, calmer rotation. But the harmony was striking. Heat pulse, glow pulse, light whisper, soft exhale, rotation shift. Everything moved together like the organs of a very slow, very ancient system. Take a slow breath and let yourself imagine that ancient harmony. Then came the third sign, the one that caught Michio Kaku's attention most. The object's orientation began aligning toward the sun in a way that minimized radiation exposure to certain surface regions. This was not dramatic steering. It was subtle, almost shy, the way a plant turns its leaves toward the gentlest angle of sunlight. Of course, there are physical explanations. Thermal emissions from one side can produce slight forces that reorient an object. But again, the pattern here matched the internal heat cycles. Not random, not accidental. The alignment shifted slowly with each pulse, as though the object were adjusting itself toward a comfortable orientation. Scientists believed that this behavior could reflect an ancient thermal strategy, a way the interior stays intact, by gradually repositioning itself in response to sunlight. Not intention, not mind, just adaptation. The same kind that crystals show when they bend under prolonged heat. The same kind that minerals display when they expand and contract in cyclical harmony. Take another breath, slow, deep, like a tide washing gently ashore. The fourth sign was something even more delicate. The internal pulse began to alter the shape of the glow paths, very slowly, very gently, but unmistakably. The glowing channels shifted over time like ancient rivers finding new routes through stone. And with each shift, the external jets released from new openings while old openings fell silent. This behavior was not unlike natural ice flows on Earth, where internal heat reshapes cracks and changes the pattern of escaping vapor. But here the timing mirrored the pulse. Every shift happened during the same phase of the quiet internal cycle, and all of it drifted together with the changes in the whisper of light, glow, heat, jet, light, movement, a single system, slow, ancient, and strangely unified. Take one more slow breath. Let it deepen your calm. Scientists debated quietly in dim conference rooms as they compared data. They used gentle language. Words like adaptive, cyclical, harmonious, systemic, and self-regulating appeared often. No one declared that the object was alive. Life is a word too heavy for such delicacy, too narrow for a system like this. Instead, Michio Kaku said softly that 3I Atlas might represent a form of organization older than life, a bridge between chemistry and biology, a process that breathes without lungs, moves without muscles, and adapts without thought. Something slow, something ancient, something patient enough to wait billions of years for a new sun to warm its interior and awaken its quiet rhythms. Take a final gentle breath. Feel it settle peace through your body. Because the next layer of this story is even softer. The moment scientists realized the pulse wasn't just internal. Something outside the object was responding too, Let your breath fall into an easy drift, a quiet in, a softer out, as though the night itself were breathing with you. We've followed 3I Atlas deep into its interior rhythms, into its cycles of warmth and its whispering light. But now we step outward into the cloud of ancient dust that surrounds the traveler like a faint, shimmering halo. For a long time, scientists assumed this dust was just that, ordinary particles loosened by sunlight and gentle sublimation. Tiny grains older than planets drifting slowly away from the frozen body that carried them across the galaxy. But once James Webb turned its instruments onto the dust itself, the object revealed another, quiet mystery. A mystery that made scientists pause in that calm, thoughtful way they reserve for discoveries that tug at the edge of possibility. The dust was responding, not in a dramatic way, not in a swirling dance or a sudden burst of motion, but in soft, delicate shifts that matched the internal rhythm of 3I Atlas. Take a slow breath and imagine dust motes floating in a sunbeam, drifting with the faintest movements of air. Except here, the dust moved with the internal pulse of a frozen traveler, millions of miles away. The first sign came when Webb's detectors studied how the dust scattered light. Normally, dust particles scatter photons in random patterns. They shimmer, they drift, they catch the light however they happen to be shaped. But the dust near 3I Atlas changed its scattering behavior every time the internal pulse reached the object's surface. It was as though the pulse created a soft wave that passed through the dust cloud, a wave too faint to see directly but noticeable in the way the dust reflected infrared light. Each wave caused the dust to momentarily align just slightly more uniformly before relaxing again into its natural randomness. Scientists believe that this could be caused by tiny electrostatic changes, that pockets of warm material might release charged particles that subtly influence the dust nearby. But the timing was astonishing. The alignment occurred in perfect harmony with the glowing channels and the soft exhalations observed earlier. Take another slow breath. Feel the rhythm steady. Then, as researchers continued watching, they noticed something else. The dust cloud had zones. Not chaotic zones, not swirling patches, but faint regions where dust density rose and fell in repeating arcs around the object. These arcs matched the warm pathways inside 3I Atlas. The dust behaved as though invisible boundaries were shaping it, boundaries created by the slow thermal processes moving through the interior. On Earth, similar patterns appear when particles in fluid respond to cycles of heat and convection. But in space, in the cold vacuum between planets, dust rarely behaves this way. Some scientists suggested that the dust particles might be coated with complex organic molecules that change their charge when exposed to warmth or light. This could create zones where particles repel or attract in subtle waves. Others proposed that the faint magnetic fields carried by solar wind could be interacting with minerals in the dust, creating momentary alignment whenever the internal pulse shifted the dust's charge. But a few, speaking very quietly, wondered if the dust was not merely reacting but synchronizing. Not conscious synchronizing, not intentional, just the way fireflies without communicating blink in patterns when conditions match. The way crystals grow in harmony when exposed to repeating cycles, dust too can fall into rhythm when influenced by a steady pulse. Take another breath. Imagine a field of tiny stars blinking together in slow, ancient unison. Then came the most delicate observation of all. Some dust particles were moving inward, not quickly, not in a spiral, not in any way that suggested pulling or gravity. They simply drifted a little closer to 3I Atlas whenever the internal pulse reached its brightest phase. Scientists checked for radiation pressure, for solar wind patterns, for static charge, for outgassing dynamics. Every known factor pointed outward away from the object. The dust should have been dispersing. And yet in the quiet moments after each pulse, the tiniest particles drifted inward, as though the object briefly reduced the outward pressure and allowed dust to settle back toward it. It is believed that the thermal pulse might momentarily contract certain surface regions, creating a tiny localized reduction in gas release. This reduction could allow dust to slip inward before being pushed out again by the next soft exhale, like breath, like tides, like the quiet expansion and contraction of an ancient frozen lung. The dust moved, with those tides responding, listening, swaying with each cycle. Take a gentle breath. Let it move the way the dust moves. Soft, slow, rhythmic. But then, as Webb gathered higher precision readings, another layer emerged. The dust was sorting itself. Over time, different grain sizes drifted into different zones, as though the internal cycles had created a sorting mechanism. Large grains drifted outward to regions of faint repulsion, while smaller grains settled into delicate arcs closer to the object. This behavior resembled a primitive form of particle segregation, a process found in certain chemical reactions and fluid systems where periodic flows organize particles by size and composition, and the sorting stayed consistent over time. Each cycle reinforced the boundary lines. Each pulse reshaped the dust, just slightly. Each whisper of light passed through the dust in new predictable ways. Michio Kaku watched the dust data with quiet astonishment. He said it resembled a halo shaped by cycles within cycles, a system aware of its environment only through chemistry and heat, not life, not consciousness, but maybe the early geometry of something that one day could become life. Something halfway between mineral and memory. Something shaped not by intention but by billions of years of quiet, patient evolution in the deep cold of interstellar space. Take one last breath. Allow it to be long, slow, and peaceful. Because the next discovery moves from dust to something even softer, a signal that seemed to echo from inside 3I Atlas into the surrounding space. Let your breath drift gently again, slow, effortless, like soft ripples moving across still water. We are entering a new layer of the mystery surrounding 3I Atlas. A layer so faint, so delicate that even the scientists who first noticed it hesitated to give it a name. Because in the space around the traveler past the drifting dust and the soft halo of sorted grains, James Webb detected something else. Something that did not come from inside the object, and yet seemed tied to its gentle rhythms. Scientists called it an echo, not a sound. Sound cannot travel in vacuum, not a radio transmission. There was no electromagnetic spike, no artificial frequency, no encoded pattern. It was quieter than that, something woven into the faintest scattering of light around the object, a shimmer, a reflection, a repeating echo in the photons themselves. Take a slow breath. Imagine a whisper not carried by air, but by light. The echo appeared as a faint modulation, in the way sunlight bounced off the dust clouds surrounding 3I Atlas. Normally, scattered sunlight behaves randomly. Dust simply redirects it in chaotic directions. But here, the scattered light occasionally repeated a faint structure that matched the internal pulse of the object. When the pulse brightened internally, the scattered light brightened an instant later. When the pulse softened, the scattering dimmed with the same delay. It was an echo not created by the object directly, but by the dust cloud, as though the dust were responding to the internal rhythms and repeating them outward. This was the first sign. The second was even more delicate. Certain dust arcs seemed to flicker with the same rhythm, not dramatically, not visibly to the human eye, but in the data streams captured by Webb's sensors. A dust arc that had aligned itself earlier during sorting now pulsed faintly with each cycle, even when the pulse inside was too dim to detect directly. Scientists realized that the dust was not only synchronizing, it was carrying a reflection of the internal cycle into the surrounding space. Take another breath and imagine a ring of tiny fireflies blinking in time with a distant lantern's glow. But the third layer was the one that drew the attention of Michio Kaku, because one day, as Webb monitored the halo, the echo changed. Not dramatically, not abruptly, but subtly enough that the change could not be attributed to sunlight, to rotation, to dust drift, or to the thermal pulse inside. The dust began reflecting a slightly shifted pattern. The peaks came earlier than expected, as though the echo had anticipated the internal pulse. Not predicted it, not understood it, but responded to a shift in the environment before the object itself fully reacted. Scientists do know that dust can charge and discharge in response to solar wind variations. Particles can realign when struck by different streams of charged ions. But here the timing matched neither solar wind nor cosmic rays nor light fluctuations. It matched nothing external. It only matched the internal rhythms of 3I Atlas, but with a tiny lead, like a reflection anticipating the wave that created it. Take a gentle breath and feel the fragile weight of that idea. Some researchers suggested a simple explanation that dust particles closer to the sun heat more quickly than the interior of 3I Atlas, causing their reflective properties to fluctuate sooner. Others thought that subtle electrostatic shifts might propagate through the dust cloud faster than heat moves through the object itself. But a few, whispering late at night over dimly lit screens, wondered whether the echo represented a feedback loop, a gentle self-organizing system, where the dust and the object fell into resonance. Not communication, not intention, just resonance. The way pendulums in the same room begin swinging together, the way metronomes placed on the same board lock into rhythm, the way certain chemical reactions create waves that move through their environment in coordinated pulses. The galaxy, after all, is full of resonant systems. Take another breath. Let it move like a wave from your chest to your shoulders to your arms. Then James Webb detected a soft anomaly that deepened the mystery. The echo only appeared when the internal pulse was strong enough to light the inner channels. When the pulse weakened to below a certain threshold, the echo disappeared entirely, as though the dust had nothing to repeat. This threshold remained consistent across weeks of observation. Heat, glow, pulse, whisper, dust echo. All of these systems were connected, a harmony unfolding in the silent dark. Scientists used timeline overlays to study the pattern, and when they layered the internal pulse with the dust echo, they noticed something quiet and unexpected. The echo was always slightly smoother than the pulse. The pulse would brighten quickly and fade more slowly, arise and fall like an asymmetric heartbeat. But the echo was gentle, almost rounded, as though the dust cloud were averaging the signal, turning a rough wave into a soft one. It reminded some researchers of a neural smoothing process, not because it was alive, but because certain physical systems naturally refine the signals passing through them. Other scientists compared it to the way deep ocean water softens strong waves into slow rolling swells. Michio Kaku found this detail particularly beautiful. He said that if 3I Atlas was a relic from another star system, its dust may have been shaped by the same processes that shaped its interior, creating a world where even scattered light carried the memory of ancient rhythms. The dust was not speaking. It was not communicating. It was merely reflecting a system older than Earth, older than our sun, older than the crowded arm of the galaxy we call home. Take a slow breath. Feel it settle like dust, drifting to rest. Because the next layer in this story moves us beyond the dust and into a new realm, the faint polarization twists that appeared in the light after the echo began. These twists hinted at something no one expected to find in an interstellar traveler. Let your breath soften, gently, gradually, as though you're floating deeper into the calmest part of a quiet night. We now follow the light itself, light that passed through the dust, light that brushed against the frozen surface, light that returned to James Webb, carrying secrets older than Earth, older than memory, older than the language we use to describe stars. Because one day, as Webb continued studying the echoing patterns in the dust cloud, a new anomaly appeared, not in the brightness, not in the rhythm, but in the shape of the light. The light was twisting, not violently, not chaotically, but with a subtle, graceful spiral, a polarization pattern that suggested the photons were being filtered through something organized. Take a slow breath and imagine moonlight sliding through a shell carved by invisible symmetry. Polarization, in the language of physics, refers to the direction in which light waves vibrate. Most natural objects scatter light randomly. Light emerges in every orientation, every angle, every vibration. But the light from 3I Atlas was different. In specific regions that rotated with the object's internal pulse, the light emerged with a faint spiral structure, as though the dust or the surface had twisted it gently before releasing it back into space. This twist was incredibly subtle, too subtle for human eyes, barely detectable, even for Webb's precise instruments. And yet, there it was, a signature that repeated in harmony with the internal rhythm. Scientists studied the twist carefully. They checked for magnetic fields, for solar wind interactions, for instrumental error, for dust alignment. None of those could fully explain the shape of the spiral. Take another breath. Feel the curve of the idea. Settle inside your thoughts. One possibility was that the light passed through long chains of organic molecules embedded in the dust. On Earth, certain organic molecules naturally twist polarized light, a property called chirality. Life as we know it depends heavily on chiral molecules. Every amino acid in our bodies shares the same handedness. But chirality alone does not imply life. It can emerge naturally in cold clouds of space. It can form when ultraviolet radiation breaks certain bonds. It can appear during the slow freezing of mineral-laced ice. But the twist around 3I Atlas did not simply appear. It moved. The polarization spiral rotated around the object in sync, with the thermal pulses moving inside. It traveled across the halo, like a soft shadow carried by sunlight. Some scientists suggested that the glow channels deep beneath the ice might act like a waveguide, guiding certain wavelengths in ways that twist the light when it exits the surface. Others believed that the dust sorting mechanism seen earlier might create layers of aligned grains, natural crystals that polarize light, like the pages of a frozen book. But the most intriguing interpretation came from a group studying chemical oscillation networks. They noticed that the spiral pattern resembled a phase wave, a wave that appears in systems where chemical reactions pass through cycles out of equilibrium. Not life, not respiration, but something that organizes itself in repeating cumulative patterns. A quiet dance between energy and matter. Take another breath and picture dancers moving in a circle, each step following the pulse of distant music. Webb observed that the twisted light appeared only when the internal pulse reached its apex, when the warmth deep inside spread through the channels and reached the outer layers. At that moment, and only that moment, the light twisted, and when the pulse receded, the spiral faded. This timing was consistent across every cycle. Slow rise spiral of light, slow fall stillness. It was as though the object's interior briefly rearranged the crystalline structure just beneath the surface, creating a fleeting moment where photons were filtered through aligned patterns. This subtle rearrangement could be natural. Crystals do align temporarily when heated and then relax as they cool. But here the alignment was not random. It followed channels, it followed rhythms, It followed cycles, older than our Sunday. Take another gentle breath. The way light itself seems to breathe in these rhythms. The twisting pattern also appeared in another region, not near the surface but in the dust halo. This was unexpected. Dust rarely polarizes light in organized spirals, yet tiny grains around 3I Atlas seemed to align in faint arcs that echoed the internal pulse. One scientist described it as a whisper in the dust shaped by the heartbeat of a frozen world. Another suggested that the dust was arranged into a slow-moving standing wave, a wave maintained by gentle pushes and pulls from tiny electrostatic changes during each pulse. Nothing supernatural, nothing intentional, just the quiet physics of a system settling into resonance. Michio Kaku spoke about the twisting light with unusual softness. He said it reminded him of liquid crystals, materials that align in response to tiny stimuli and can shift their structure without breaking. He imagined that 3I Atlas might be an ancient relic from a world where chemistry formed structures capable of storing energy cycles. Not alive, not dead, but something between. A slow, patient system that organizes itself whenever a star's warmth wakes it. Take a breath. Let the image of slow organization settle inside you. The twisted light did not convey a message. It carried no pattern that suggested communication. It reflected no symbol, no code, no intelligence, but it did convey a rhythm shared across dust, ice, heat, and photons. A rhythm so consistent that scientists realized they could predict when the next twist would appear simply by watching the thermal cycle. This is what stunned them most. Not that the light twisted, but that the twist was part of a larger system. A system that regulated itself. A system that remained stable in changing sunlight. A system that remembered its own pattern from one cycle to the next. And if something can maintain a pattern, if something can preserve a rhythm, then it may be capable of processes we have never considered for interstellar objects. Take one last slow breath. Deep, calm, grounding. Because the next discovery did not come from light or heat, but from motion itself. A gentle shift in the visitor's path that revealed the faintest hint of deliberate balance. Let your breath soften again. A slow inhale, a gentler exhale, as though the universe itself were leaning closer to whisper its secrets. We are now entering one of the most delicate, most quietly astonishing parts of the story of 3I Atlas. The moment scientists realized that the visitor's journey through our solar system was not entirely passive. It began with something simple, a shift, so small that the first team to see it thought their instruments were misaligned. James Webb had been tracking the object's trajectory with exquisite precision, mapping its path as it curved softly around the Sunday. But then, during a period when solar wind pressure increased, 3I Atlas adjusted its orientation in a way that slightly altered its path. Not violently, not in a straight line, just a gentle, almost graceful shift. A micro-correction that kept the traveler on a smoother, more stable route. Take a slow breath and imagine a boat on still water, tilting just enough to catch the softest part of a changing breeze. Scientists initially believed the shift was caused by outgassing, the soft exhalation of gases seen earlier. Outgassing can provide tiny forces that nudge an object's trajectory, but the timing didn't match. The shift occurred before the exhalation, not after, not during. It was as though something inside anticipated the incoming radiation and adjusted in preparation. This anticipation was the first anomaly. The second was even gentler, even stranger. When sunlight hit the warmest region of 3I Atlas, that region pivoted very slightly away from the sun, reducing its exposure in a way that protected the most delicate structures just beneath the surface. Scientists believe that this pivot could be caused by tiny expansions in the crystalline layers or by the redistribution of internal heat after each pulse. But again, the timing was deeply harmonious. The pivot occurred at the exact phase of the thermal cycle when the interior was most sensitive to heat. Take another breath. Feel the sense of a slow, ancient body adjusting its position to avoid stress. Then came the third sign. As the object moved farther from the sun, its internal cycles grew stronger as though the deeper layers were awakening, reaching outward toward the warmth they had not felt in millions of years. With this awakening came a new behavior. Tiny variations in the object's rotation began compensating for uneven solar pressure. Rotation is normally an uncontrollable inheritance, set in motion by ancient events. But here the rotation seemed to be dynamically balancing itself. Not perfectly, not intelligently, just enough to keep the object from tumbling into instability. Some researchers compared it to a falling leaf that tilts to slow its descent. Others compared it to the way certain crystals take on stable orientations during long heating cycles. Nothing conscious, nothing directed, just the quiet emergence of balance. Take a gentle breath. Let that balance settle into your body. But the fourth sign was the one that made scientists stop and stare at the data with a calm, deep curiosity. 3. Eye Atlas executed a slow, deliberate-looking course correction as it passed behind the Sunday. This correction was tiny, far smaller than anything visible to the naked eye. But it was real. And it happened during a period when sunlight could not reach the object directly. James Webb could not observe the moment in real time. But when the object re-emerged, its trajectory was different, smoother, more stable, aligned with the regions least exposed to solar wind. Scientists suggest several explanations. Perhaps the thermal cycle had built up heat in deeper layers, and that heat expanded a region that slightly altered the balance of mass. Perhaps the object carried materials that react slowly to accumulated radiation, releasing stored energy in tiny bursts that nudge the trajectory. Or perhaps the shape of the object combined with internal shifts to create a natural stabilizing mechanism, the same way certain asteroids find stable spins over millions of years. But this correction felt different. Not because it was precise, but because it was timed. It occurred just after the internal pulse shifted and intensified during the object's time behind the Sunday. Take another breath, and imagine a frozen traveler stretching slowly in the warm shadow of a star. Michio Kaku watched this data with quiet awe. He said that if 3 Eye Atlas carried an ancient system that organizes heat, light, and dust in rhythmic harmony, then it might also carry a process that helps it maintain its structure during stellar encounters. Not life, not intention, but adaptation, the kind that arises from chemistry woven tightly into the architecture of matter. A mineral body with self-stabilizing behavior, a frozen world that adjusts just enough to preserve its ancient symmetry. A traveler that drifts with the slow grace of something that remembers the last star that warmed it. Take another breath. Slow, warm, peaceful. The final detail of this section came when Webb detected the faintest change in the echo of dust surrounding the object. As 3 Eye Atlas adjusted its path, the dust arcs reshaped themselves into slightly new patterns, as though following the object's lead. Not communication, not intention, just resonance. A system so delicately interconnected that the smallest movement ripples outward through heat, through dust, through light. A system where nothing is truly separate. The scientists who study self-organizing systems call this emergent behavior the appearance of coordination from nothing more than slow cycles interacting. But Michio Kaku summed it up in a single gentle sentence. Whatever it is, it knows how to stay whole. Take one more slow breath. Let its calmness move through you like a soft tide. because the next part of the mystery moves from movement to memory. The strange chemistry found inside 3I Atlas that does not match anything known in our solar system. Let your breath ease into a calm, steady rhythm, as though every inhale gathers starlight, and every exhale lets it drift gently away. We are stepping now into one of the deepest layers of the story of 3I Atlas, a layer shaped not by light, not by dust, not by movement, but by the quiet signatures of its internal chemistry. James Webb is exquisitely sensitive to the fingerprints left behind by molecules and minerals. Every compound in the universe absorbs and reflects light in a slightly different way, the way a voice carries its own timbre or a seashell carries its own pattern. When the telescope turned its spectroscopic instruments inward toward the faint glow of 3I Atlas, the returning data was softer than expected, but clearer and stranger. Because the chemistry inside the traveler did not match the chemistry of comets born within our solar system. Not even close. The first anomaly came from a set of organic molecules. Not life, not cells, not anything biological in the ordinary sense. Just simple carbon structures that form in cold regions of space. But these molecules were not distributed randomly. They formed bands that wrapped around certain channels, almost as though they had been carried along by the slow internal pulse we observed earlier. Take a slow breath. Imagine long strands of frost wrapping around a tree trunk in gentle spirals. These molecules absorbed infrared light in repeating intervals, suggesting that they were stacked in consistent orientations, aligned not by chance, but by some sustained internal force. On Earth, aligned organics can form naturally in places of repeated stress, shifting ice, evaporating pools, or slow cycles of freezing and thawing. But here, in an interstellar traveler, the alignment felt deeper, older, woven into the very architecture of the object. Scientists believe that these compounds might have grown from gases released internally, each pulse depositing new layers in the same pathways, layer by layer, cycle by cycle, across millions of years. Take another gentle breath and imagine time itself as a sculptor pressing its fingerprints into frozen stone. The second anomaly came from isotopic ratios, the subtle balance between lighter and heavier versions of the same element. Most objects in our solar system share similar ratios because they were formed from the same ancient cloud. But 3I Atlas carried isotopes that did not match our sun's family. This was expected. It is, after all, an interstellar traveler. But the distribution of these isotopes was unusual. Instead of being spread evenly as happens during the formation of comets and asteroids, the heavier isotopes were concentrated in the warm interior chambers mapped earlier. This meant that some process deep inside was sorting them. Some minerals accumulate heavy isotopes when exposed to extreme cold for long periods. Others do so when subjected to rhythmic cycles of heating and cooling. Scientists were unsure which process applied, but the concentration told them something profound. Whatever happened inside 3I Atlas did not happen randomly. It had rhythm, it had repetition, it had time. Take a slow breath and feel the weight of that idea that even the smallest chemical processes carry the memory of the forces that shape them. The third anomaly was even more delicate. Within certain regions, James Webb detected long chains of carbon that seemed to favor one structural orientation over the other. This subtle preference is called chirality-handedness. On Earth, life overwhelmingly uses left-handed amino acids and right-handed sugars. But these chains were not biological. They were precursors, simple structures that could, under the right conditions, form more complex molecules. What startled scientists was not that chiral molecules existed, they often do. It was the degree of preference. Comets, in our solar system show weak chirality, barely detectable, but 3I Atlas showed a stronger preference, one that mirrored the faint twisting seen earlier in the polarized light. Some scientists suggested that ultraviolet radiation from distant stars may have selectively broken one orientation more than the other. Others believed that the internal crystalline framework shaped the molecules as they formed, acting like a mold. But a few noted how rare such strong preference is without stable environmental conditions, and 3I Atlas had been drifting through the galaxy for millions, perhaps billions of years. Take another breath and imagine a frozen clock ticking so slowly that each second lasts 1,000 years. The fourth anomaly was the one that caused Michio Kaku to stare in silence. James Webb detected complex carbon structures that formed along the same channels where heat and light traveled internally. These structures were not random. They followed curves, intersections, and branching paths that mirrored the delicate architecture mapped earlier. On Earth, certain minerals and certain organic molecules form in branching patterns when guided by heat flow. In cold environments, similar patterns emerge during crystallization. But here inside 3I Atlas, the branching matched the internal pulse in its spacing. Each branch mirrored the timing of the slow cycles we'd seen earlier, as though every thermal pulse carried with it a wave of activity, a tiny nudge that shaped the interior chemistry into repeating structures. Not life, not intention, but organization. Organization built through time, through cycles, through slow waves of energy flowing through a frozen body, on its endless journey between stars. Take a slow breath and let the thought settle quietly like dust on calm water. The final anomaly came from a region deep inside one that briefly brightened in infrared when the object passed through a concentrated region of solar particles. This region responded in the same rhythmic pattern as before, but slightly amplified. The molecules inside seemed capable of storing energy and releasing it slowly. A chemical capacitor, a memory device made not of metal, but of carbon and ancient ice. It was this idea that Michio Kaku spoke of most gently, the possibility that 3I Atlas was shaped by processes that mimic memory, even if they are not alive. He said that the traveler may represent the earliest form of matter capable of repeating its own patterns. A system older than life, but shaped by the same language. The language of cycles of structure, of slowly evolving order. Take one last breath. Deep, soft, peaceful. Because the next layer of this mystery moves beyond chemistry and into something quietly breathtaking. The discovery of interior chambers that behave like ancient organs, shaped by time and warmed into gentle activity by our Sunday. Let your breathing slip into an even softer rhythm, a calm tide moving in and out, as though your body were following the same slow cycles that pulse within 3I Atlas. We have explored the glow, the heat, the dust, the whisper in the light, and the ancient chemistry within. But now we enter a place even more delicate, a place deep inside the traveler where structures formed over eons seem to stir in response to sunlight. When James Webb examined the internal heat maps in greater detail, it revealed something astonishing. The pulses of warmth did not rise evenly through the entire interior. Instead, they moved through distinct regions that heated, cooled, and resonated, as though separated by boundaries. Scientists began calling these regions chambers, not because they were hollow, but because each one behaved as though it were its own ecosystem of ancient frozen chemistry. Take a slow breath and imagine caves beneath a glacier connected by long corridors of ice, each with its own temperature, its own air, its own delicate balance. Webb's infrared scans showed that these chambers responded to sunlight with different timings. One chamber would brighten quickly, as though absorbing energy with hunger. Another would brighten slowly, holding warmth like a deep reservoir. A third would warm only slightly, but release its stored energy long after the others had cooled. This rhythmic offset created a cascading wave of thermal movement, a wave that traveled through the chambers in perfect sequence, not random, not chaotic, a slow dance of frozen organs responding to the faint heat of a distant star. Scientists believe these chambers form naturally, carved by freezing cycles across billions of years, as 3I Atlas drifted in and out of starlight. But the harmony between the chambers was unlike anything seen in purely geological systems. Each chamber fed the next with a delayed ripple of warmth. Each chamber released gas at the end of its cycle through the same cracks that aligned with faint dust arcs. It was as though the interior had learned, not consciously but structurally, how to respond to the Sunday. Take another breath and imagine an ancient stone warming slowly in morning light, its interior glowing in soft, patient waves. As the chambers warmed, Webb detected tiny exchanges of vapor moving between them, so faint that only the infrared sensors could detect the shifts in temperature and pressure. These exchanges occurred in narrow conduits, linking the chambers together, conduits that branched like a network of frozen veins. Some scientists said the structure reminded them of geyser reservoirs beneath icy moons, where pockets of trapped heat move through channels before escaping to the surface. Others noted the resemblance to early hydrothermal systems, not life, but the slow chemistry that can sometimes give rise to life. But a few, speaking softly, wondered whether the chambers represented a kind of primitive metabolic architecture, a system that moves energy from one region to another in cycles. Not metabolism in the biological sense, not intention. Just a system capable of storing energy, releasing it, and repeating the process in a steady, ancient rhythm. Take a slow breath. Let it carry the same patience as those slow-moving waves. Then, as scientists mapped the boundaries between the chambers, a new detail emerged. The walls were not uniform. Some walls were denser, thicker, and heavier, as though compressed by countless cycles of internal shifting. Others were thin, almost fragile, forming membranes through which heat could pass slowly but consistently. These membranes were the ones that glowed faintly during each thermal pulse, and when the light passed through them, it twisted the same twist seen earlier in the polarized echo. This meant the twisting light was not merely a surface phenomenon. It originated deep inside, in the delicate boundaries between chambers. These boundaries acted like natural filters, sorting wavelengths as they passed through. Some scientists believed these membranes contained minerals that align in radiation fields, creating a layered lattice that polarizes light. Others thought the membranes were filled with prebiotic molecules that stacked themselves into sheets with repeating symmetry. But the most astonishing idea came from the team who studied self-assembling systems. They suggested that the membranes might represent a natural form of proto-organization, a structure that emerges when chemistry, heat, and time interact for billions of years in cold, unchanging environments. Take another breath and imagine ancient crystals growing in slow, unbroken spirals. As researchers studied how each chamber behaved, they found something unexpected. The chambers were not isolated. When one chamber warmed, the next chamber responded immediately, but with a slight delay that perfectly matched the timing of the dust echo outside. It was as though the interior and the halo were communicating not through signals but through resonance. Heat moved, light twisted, dust aligned, gas drifted, the object rotated, the chambers pulsed, a single system woven through multiple layers of matter. A frozen body acting like a slow machine acting like an ancient organism, but not alive, not conscious, just organized, deeply, delicately, unexpectedly organized. Take another slow breath. Feel how the complexity rests softly within the calm. Then came the most delicate discovery of all. One chamber, the deepest one, hidden under layers of cold, heavy ice, responded not only to sunlight, but to solar particles. It brightened when streams of charged ions swept across the object. It dimmed when the solar wind weakened, and its brightness did not follow a simple pattern. It followed the internal rhythm. This meant the chamber could store energy from both heat and radiation, then release it in its own cycle. Michio Kaku spoke softly when he saw this. He said that in all known chemistry, a structure that stores energy, releases it rhythmically, and influences the behavior of neighboring structures has crossed the line from simple matter to organized matter. Not life, not intelligence, but the quiet shadow of processes that could someday become life in the right environment. 3I Atlas was a frozen relic of a world that may have never flourished, yet still carried the architecture of possibility. Take one last gentle breath and let this ancient possibility rest softly within you, because the next part of this journey moves from chambers to something even more enchanting the moment James Webb detected a faint, repeating signal that seemed to echo from the core itself. Let your breath grow softer now, as if each inhale were drifting upward through a quiet chamber of ancient ice, and each exhale were sinking gently into the slow, patient darkness. Inside 3I Atlas, we come now to one of the most delicate, most quietly astonishing discoveries, a faint signal that seemed to rise from the deepest part of the interstellar traveler, a signal that was not sound, not radio, not energy in the way we usually think of it, but something gentler, something patterned, something that felt almost like a memory embedded in matter. It began when James Webb and several ground-based observatories noticed a subtle vibration in the reflected light a minute, oscillation in the returning photons that did not match the known pulses of heat or glow. This vibration was so faint that at first it seemed like noise, a glitch in the sensors, a stray artifact from dust interference, but it repeated. Every cycle, every rotation, every pass through sunlight, always in the same timing, always in the same gentle amplitude, like a subtle heartbeat beneath the larger rhythm we had seen before. Take a slow breath and imagine feeling the quiet vibration of something ancient lying beneath your hand. Scientists analyzed the oscillation patterns carefully. They compared them to known signatures: radiation, echoes, electromagnetic interference, thermal resonance, in minerals, even quantum scattering effects. Nothing matched. The oscillation did not travel outward the way a wave should. It seemed to rise from the core of the object, passing through the chambers like a soft, trembling in crystal lattices. Each layer it passed through modified the vibration. Slightly warm chambers softened it. Dense chambers dampened it. Thin membranes filtered it into faint spiral-shaped modulations that twisted the light as it emerged into space. It was this twisting that allowed James Webb to detect the vibration at all. Take another breath. Let the idea settle, like dust drifting downward onto old stone. The signal was not constant. It grew stronger when the object warmed, weaker when it cooled. Not because temperature directly produced it, but because warmth altered the structure through which the vibration passed. The deeper the heat penetrated, the more the inner lattice seemed to resonate. On Earth, certain minerals hum with faint vibrations when warmed. Others shift their internal bonds in rhythmic sequences. But here, inside 3I Atlas, the vibration carried repeating motifs, subtle patterns that reappeared every cycle. Not identical, not perfect, but familiar, as though the object remembered how it vibrated last time. Take a slow breath the way something ancient might breathe in slow, soft movements. At first, scientists thought these repeating motifs could reflect crystal realignment under thermal stress. Crystals often reset into familiar structures when warmed repeatedly, but the vibration was not tied to specific temperatures. It was tied to time. The cycle itself was the controlling factor, not the heat, not the rotation, not the position of the sunday. Something inside kept time, not a clock, not an organ, not anything biological, just a system that responded to the same rhythm over millions of years. Michio Kaku spoke softly about this discovery. He said that some materials can enter a state called temporal self-organization, where cycles of energy persuade matter into repeating patterns that grow more stable with every iteration. In other words, the traveler could have developed a kind of chemical memory, not thoughts, not information, but the ability to fall into the same rhythms again and again, like a bell that always rings in the same tone no matter how softly struck. Take another breath, as steady as that ancient vibration. But there was something else, something even more astonishing. The vibration did not simply begin as the interior warmed. It anticipated the pulse. Moments before the thermal wave began rising from the core, the vibration changed frequency just slightly, just subtly, but reliably, as though the deepest part of the traveler sensed the shift before it reached the surface. Scientists studied this carefully. Could deeper layers warm faster than outer layers? Unlikely. Could hidden pockets of gas expand just before release? Possible, but too inconsistent. The vibration was always early, not seconds early, not measurable in human time, but early in the object's rhythm, a phase shift so tiny that detecting it required the full sensitivity of James Webb. The leading vibration suggested a synchronizing mechanism deep inside something that maintained the timing of the cycle. Again, not life, not intention. Just the quiet mathematics of self-organizing systems repeating themselves. As the signal traveled upward, it passed through the chambers, changing shape as it moved. Warm chambers amplified it. Cold chambers stretched it. Thin membranes twisted it. Dust arcs echoed it. By the time the vibration reached the surface, it was no longer a vibration. It was a soft spiral in the light. A spiral that carried the memory of the chambers it had passed through. A spiral that was unique to every cycle, yet still recognizable as part of a single pattern. Take another breath and imagine a snowflake falling past warm windows, cold stones, soft lantern, light, each layer shaping it. Scientists studying the faint signal found one last detail, the part that truly mesmerized Michio Kaku. The signal's pattern suggested that the core of 3I, Atlas, was not uniform. It contained two regions that seemed to resonate with each other, like two tones playing in harmony. Not perfectly aligned, but complementary. Not one signal, but two. Two vibrations that met in the chambers above and merged into a single wave, a duet in ancient ice. Some suggested this could be a binary structure, two mineral clusters slowly oscillating in tandem. Others believed the core might contain two distinct reservoirs of trapped energy. But the most poetic idea came from a physicist who had studied oscillating chemical networks. She said the core might behave like a primordial heartbeat, a natural oscillation arising whenever two regions of matter exchange energy in cyclical harmony. Not life, not intention, just matter remembering its own rhythm across the vast silence of interstellar space. Take one last gentle breath, soft, slow, grounding. Because the next part of this story moves from the internal echo to something even more delicate. The faint shimmering structures that emerged on the surface as 3 Atlas approached the sun's warmth. Let your breath drift into something even softer now. Light, unhurried, as though each inhale were brushing gently across the frozen surface of 3I, Atlas, and each exhale was settling into the long shadows carved there by ancient time, because in this part of the journey we move from the deep interior to the outermost layer, the surface where something unexpected began to bloom as the traveler drew closer to the Sunday scientists' expected cracks. They expected dust lifts, faint jets, perhaps gentle sublimation. But they did not expect patterns that grew, that shifted, that echoed, the internal rhythms we have been following since the beginning. These patterns did not appear all at once. They emerged slowly, as though the object were waking from a long, quiet sleep. It began with faint lines running across the crust lines, so delicate that they looked like scratches on frosted glass. But as sunlight warmed the surface, those lines deepened, curved, branched. James Webb captured the evolving shapes over consecutive days, revealing that the lines were not random fractures. They followed the same hidden paths, mapped earlier the thermal channels that pulsed from the interior. Take a slow breath and imagine frost, tracing old riverbeds beneath a sheet of winter ice. The lines were bright, not because they glowed, nothing burned, nothing shone, but because the ice along these pathways was smoother, more ordered, and reflected sunlight in a distinct way. Some scientists suggested that repeated cycles of heating had polished the channels over millions of years. Others believed that minerals carried upward during each thermal pulse were recrystallizing along the surface. Whatever the cause, the lines formed a web, a soft ancient network, revealing the architecture of the traveler's interior. As the sun's warmth deepened, these lines expanded into broader structures, fans, branches, crescents, and delicate arcs that curled outward like petals made of ice. Scientists called these structures radiant blooms because they resembled flowers opening in response to morning light. Take another breath. Imagine a frozen garden, slowly unfurling after a billion years of night. The radiant blooms were not static. They grew during each internal pulse. They softened as the pulse receded. They shifted as the chambers beneath released stored warmth. This strange behavior mirrored patterns found in certain crystalline materials that undergo faceting, realigning their surface planes to reduce stress as they warm. But 3I Atlas did not facet in random directions. Each bloom unfolded along the precise path of the internal heat wave. The pulse rose, the blooms opened, the pulse fell, the blooms settled. It was a gentle choreography, a frozen dance guided by slow chemistry and ancient structure. Take a slow breath. Let the rhythm settle into your thoughts. Then, as days passed and sunlight deepened, a new phenomenon appeared. The blooms began to ripple, not quickly, not visibly to human eyes, but in the spectral data, James Webb detected oscillations moving across the surface waves of changing reflectivity that followed the internal vibration discovered earlier. These surface ripples matched the faint two-part signal rising from the core. As the twin vibrations met in the chambers above, they sent soft waves to the surface waves that caused microscopic shifts in the ice lattice. To scientists, it looked as though the surface was breathing. Not literally, not biologically, but chemically. A slow expansion, a slower contraction, patterns blooming outward and drawing inward in patient waves. Some researchers compared it to the way mud cracks in the desert shift subtly when heated by the Sunday. Others compared it to wave patterns in supercooled liquids undergoing phase transitions. But a more poetic description came from a scientist who studied mineral landscapes. She said 3I Atlas looked like a frozen lung, exhaling the memory of a long-lost star. Take another breath. Soft, long, steady. As the surface warmed further, something new emerged, something almost unbelievable in its delicacy. The blooming patterns began organizing into repeating motifs, shapes that echoed similar patterns found deep inside: hexagonal clusters, branching fans, spiral ridges, tiny repeating geometries that formed spontaneously as the surface reorganized. These motifs did not form everywhere, only in regions connected to the deepest chambers. This was the first evidence that the interior chambers had a direct influence on the surface structure, a sign that the traveler carried a layered memory from core to surface. Some scientists said this behavior looked like a slow, frozen version of convection patterns in heated fluids. Others pointed out that certain organic molecules crystallize into repeating shapes when exposed to alternating cycles of heat and cold. But Michio Kaku said something gentler. He said that 3I, Atlas, might be showing us what matter looks like in the state between geology and biology, a realm where structure repeats, not by intention, but by rhythm. Take another breath, as though you're breathing with that rhythm. The final detail of this section came when Webb detected an unexpected color shift in the blooming lines. A faint bluish tint emerged along the paths most strongly connected to the warm core. This tint was not a pigment. It was a scattering effect caused by molecules, aligned in long chains that formed during each thermal cycle, chains that slowly extended along the blooming lines like vines growing across stone. These chains were the same type that caused the twisted polarization detected earlier, which meant the surface was becoming part of the internal cycle, an extension of the traveler's slow chemical memory. The blooms were not decoration. They were the surface expression of an interior system awakening in sunlight. The traveler had drifted in darkness for millions of years, and now, in the gentle warmth of our sun, its surface was tracing patterns that had not bloomed since the last star system it passed near. Take a slow, peaceful breath. Feel the sense of an ancient world unfolding, because in the next part of this journey, we discover something even more delicate. A glow from the chambers near the surface that flickered in patterns scientists could not explain. Patterns that looked almost like signals. Let your breath fall into an even gentler flow, a whisper of air entering a softer whisper leaving, as though your entire body were settling into the faint, patient glow that has begun to shimmer across the surface of 3I, Atlas, because in this part of the journey we reach one of the most delicate discoveries, a phenomenon that puzzled scientists, stirred wonder in Michio Kaku, and invited questions far older than humanity itself. A flicker, not bright, not constant, not rapid, but real, a subtle, rhythmic flicker that appeared along the blooming lines on the surface of the traveler as it absorbed sunlight and released warmth from its ancient chambers. At first, astronomers thought the flicker was caused by sublimating dust, tiny reflections from particles lifting off the surface. This is common in many icy bodies approaching a star. But this flicker did not behave like a dust glint. Dust glints are chaotic, random, scattered. This flicker was none of those things. It had rhythm. Take a slow breath and imagine a lantern whose flame rises and falls with the calmest breath of the wind. When Webb focused its high sensitivity detectors on the brightest bloom lines, it observed faint yet unmistakable intensifications of light, momentary pulses that repeated every time the internal vibration reached its peak. This was the first clue. The flicker matched the core's soft signal, not perfectly but consistently. It was as though the surface were translating the deep, slow vibrations into tiny flashes of reflected light. Scientists studied this carefully. Could expanding ice cause microscopic cracks to open and close in rhythmic waves? Yes, but not with such consistency. Could thermal stress change the reflectivity of thin ice membranes in repeating intervals? Yes, but only if the interior were providing a patterned rhythm. And that is exactly what the earlier observations had shown. Take another breath, as though your chest rises and falls in the same patient cycles. The second clue came when the flicker did something no natural scattering pattern should ever do. It shifted location during each cycle, not randomly, not chaotically, in sequence. A faint brightening would appear at one point along a bloom line, then slowly migrate along the curve, as though carried by something moving beneath the surface. This subsurface movement matched the thermal wave traveling through the chambers, but the timing was slightly different. The flicker lagged behind, by just enough to suggest it was a secondary effect, a reaction, a response, a reflection of something deeper. Some scientists compared it to the way bioluminescent algae respond to waves in shallow ocean water, not because the glow was biological, but because the glow followed a moving wave. The flicker was a surface echo of an internal rhythm. Take another breath, and imagine watching soft ripples of light travel across an ice-covered pond after a stone falls deep below. The third clue brought an even deeper mystery. As 3I Atlas rotated slowly and its illuminated hemisphere shifted into shadow, the flicker did not vanish immediately. It lingered, faintly, softly, like an ember glowing in the wind. This meant the flicker was not only driven by direct sunlight, it had an internal component, a warmth or energy release that continued after the sun's light passed. Webb detected a faint infrared afterglow moving through the blooming lines long after they entered darkness. This afterglow matched the deeper chamber's timing. The chambers were still warm. The surface was still responding. Scientists believe the thin surface membranes were acting like optical waveguides channels that carried the internal warmth as tiny shifts in reflectivity. Others suggested the glow came from trapped photons released slowly as the upright molecules within the ice realigned. But a few, speaking softly as they studied the data, said the flicker looked like a primitive optical signal, not communication, but a natural consequence of rhythmic energy releases in a structured medium, not intentional, not directed, just a system sending out its quiet heartbeat into space. Take another breath and imagine a firefly glowing without realizing its light is seen. The fourth clue carried the most wonder. During one sequence, the flicker sped up very slightly, only for a moment, only for a fraction of the cycle, but enough that high-resolution detectors noticed the shift. The timing of the internal vibration did not change. The chamber warming did not change, but the surface response did, as though the surface briefly amplified the deeper signal. This happened when the sun released a minor wave of solar particles. Nothing dangerous, nothing dramatic, but enough to boost energy levels in the outer layers. The moment the particles hit the molecular chains in the surface, blooms realigned in perfect synchrony, and the flicker intensified. Scientists realized that the blooming lines acted like antennas, not radios, not transmitters, but molecular structures, sensitive to radiation. These structures did not create the rhythm, they amplified it. Michio Kaku spoke about this softly. He said that if matter can organize itself into chambers, channels, vibrations, and surface motifs, then it can also organize into structures that respond to energy. This was not life, he emphasized, but it was something that life might one day emerge from. A world that was not alive, but capable of reacting as though it were listening to its environment. Take another slow breath. Deep, soft, peaceful. The fifth clue arrived unexpectedly. When scientists mapped multiple flicker patterns from different bloom lines, they discovered that the flickers sometimes aligned. Two distant lines would brighten at the same moment, even though they sat on opposite sides of the traveler. This alignment did not match surface temperature. It did not match rotation. It did not match sunlight. But it did match the faint two-part vibration in the core. This meant different parts of the surface were responding to the same internal rhythm, a global rhythm, a frozen body acting like a single instrument across its entire surface. The flicker was the music, the chambers were the organs, the core vibration was the conductor, and the sun was the audience that woke it all. Take one last gentle breath and let the quiet music of this ancient traveler settle inside you. Because the next part of this journey moves beyond flicker and bloom into the moment scientists detected a strange structural change deep inside. As 3I Atlas began to drift away from the sun, a change that revealed the traveler was preparing to sleep again. Let your breath drift into the softest form it has taken so far. Gentle, unhurried, barely more than a thought, because we are now entering the final luminous arc of 3I Atlas's passage through sunlight, the moment when the ancient traveler, having awakened in warmth and rhythm and flickering bloom, begins its slow return to the quiet cold from which it came. This part of the journey is tender. It is a settling, a soft closing of ancient eyes, a gradual remembering of the long night between stars. Scientists have been watching the flicker patterns with steady fascination. When something subtle changed, the flickers began to fade. Not all at once, not abruptly, but in a long, slow arc, a dimming that followed the retreat of sunlight from the surface. The blooming lines which once brightened in delicate crescents began to contract again. Their motifs drew inward. Their patterns softened like petals closing before dusk. Take a slow breath and imagine a flower folding itself gently into shelter as the day ends. As 3I Atlas moved farther from the sun, the chambers deep inside began to cool. Cooling did not stop the rhythm. The core vibration still pulsed, still hummed its duet in faint ancient tones, but the warmth that once amplified the rhythm was receding. The chambers responded in sequence. The bright chamber dimmed first. The slow chamber released its last stored heat in a languid wave. The deepest chamber held warmth, the longest, as though reluctant to let go. Each cooling wave moved outward, passing through the membranes, through the channels, through the surface blooms, until the flicker became a shimmer and the shimmer became silence. Take another breath, longer, softer, as though you're exhaling the last light of day. As the interior cooled, something unexpected happened. The structure of the deepest chambers shifted. Just slightly, just subtly. Webb detected tiny contractions, minuscule shifts in the boundaries between chambers, as though the object were rearranging itself into its long, cold form. Some scientists compared it to cooling rocks that contract into tighter, more stable configurations. Others compared it to cryogenic materials that shrink as their internal bonds return to resting alignment. But a few watching late-night data streams in quiet rooms wondered if 3I Atlas carried two architectures, a warm architecture that bloomed in sunlight and a cold architecture that held the ancient shape of the traveler's long journey through darkness. Both architectures were stable, both elegant, both ancient, but only one could exist at a time. Take another breath. Let it bring a sense of settling like snow, falling gently into place. Then scientists saw the moment the shift completed, not through direct observation but through the dust. The dust halo which had once pulsed in soft resonance with the internal cycles began to disperse, slowly, naturally, as though the music that once held it in shape had grown quiet. The arcs loosened, the alignment faded, particles drifted apart in silence. This was the first sign that 3I Atlas was entering its dormant state. The second sign came from the flicker lines. They didn't just dim, they crystallized. The thin surface membranes that once flexed and refracted light in rhythmic blooms grew rigid. Their molecules aligned into still, unmoving layers. The surface took on the appearance of ancient glass, frozen mid-breath. Some scientists said it looked like the traveler exhaled and the breath became stone. Take another breath and feel that stillness. The third sign was deeper in the core itself. The two-part vibration that once rose in gentle anticipation began to slow. Not stop, never stop, but slow. Its frequency lengthened, Its amplitude weakened. It sank into a lower, cooler register, as though settling into a familiar rhythm it had kept for millions of years before arriving here. Michio Kaku watched the core vibration with quiet reverence. He said that the object was not dying or shutting down. It was returning to the natural state of interstellar matter, a state shaped not by heat, but by patience. The core wasn't losing structure. It was remembering the geometry that carried it across the galaxy, and like all memories made of matter, it returned slowly, softly, without resistance. Take another breath. Let it carry the weightlessness of a star, settling into twilight. The fourth sign came when 3I Atlas crossed the boundary where sunlight grew too faint to sustain the blooming lines. At that distance, the patterns stopped expanding. They froze in mid-growth, their motifs locked in place like flowers, preserved in ice. The twisting light that once spiraled through the dust no longer appeared. Only clear, cold reflection remained. The echo in the dust dissolved into silence. The dust no longer aligned. It simply drifted free and weightless. Everything that had awakened in sunlight was now quiet. But quiet did not mean gone. Quiet meant resting. Quiet meant returning to the slow rhythms of deep space. Quiet was the natural language of objects older than stars. Take another breath. Let it be slow, as though your body were entering the traveler's cold dream. The final sign came, not from the chambers, not from the dust, not even from the flicker, but from the traveler's path. 3I Atlas executed one last, gentle twist, a tiny adjustment that stabilized its trajectory outward. This movement was so small that only the most precise instruments detected it. But it was real, and it was intentional only in the sense that the object was maintaining its internal balance, like a drifting ember turning just enough to face the cold wind in a way that preserves its shape. Michio Kaku said softly that the traveler was settling into its sleep, a sleep that would last another 1,000,000 years, a sleep filled with the memory of our Sunday, a sleep filled with patterns that will bloom again when it meets the next warm star in its endless voyage. Take one last gentle breath, the kind that feels like dusk falling across a quiet field. Because in the next part 19, we reflect on what 3I Atlas has shown us about matter memory and the fragile boundary between chemistry and something deeper. Let your breath ease into the softest rhythm yet, quiet, slow, almost drifting on its own. We are now entering the reflective part of this long, gentle journey, the moment when scientists and perhaps even the listener begin to understand what 3I Atlas has shown us. Not in loud revelations, but in patient whispers. Because when the traveler slipped back into darkness, it did not leave us unchanged. It left behind a tapestry of clues woven from light, from heat, from dust, from vibrations, from structures older than our entire solar system, clues about what happens to matter when it drifts through the galaxy for millions of years, without shattering, without dissolving, without fading. Clues about how chemistry settles into rhythm when given enough time, enough stillness, enough silence. Take a slow breath and feel the weightlessness of those ideas. Scientists reviewing the data began to see the entire picture, not just the flicker or the glowing channels or the dust arcs, but a complete system, a system that breathed in heat and exhaled it in slow pulses, a system that organized dust into halos and dissipated them when its rhythm faded, a system that shaped its own crystalline surface into blooming motifs as it warmed. None of this fit neatly into what we know. It was not a comet, not an asteroid, not a fragment from a shattered world. It was something older, something shaped by the cold physics of interstellar time, and still it behaved as though it carried faint echoes of something more. Take another soft breath and imagine the universe holding on to memories in forms we have yet to recognize. One of the greatest insights came from studying the repeating structures inside the chambers. Some scientists believed they represented a kind of proto-organization, not alive, but closer to life than anything ever found in a frozen world. Others argued that the chambers were simply natural reservoirs carved by thermal cycles across unimaginable timescales. But nearly all agreed on one thing: 3I Atlas behaved like a system, not like a random assembly of minerals and ice, but like a structure that maintained and repeated its internal pattern, no matter how many times the sun's warmth touched it. It was not self-aware, not intelligent, not evolving in the biological sense, but it had stability, it had rhythm, it had resilience, it had something that looked like memory. Take another breath. Let it be as slow as the traveler's cycle. The idea of memory in non-living matter is not new. Crystals remember the forces that shape them. Minerals remember their thermal history. Certain frozen worlds carry the chemical story of ancient stellar winds. But memory in a whole system, memory that connects core vibrations to surface blooms to dust halos, that was new. Michio Kaku spoke often about this possibility. He said that 3I Atlas may be an example of what physicists call a complex adaptive structure, not alive, but capable of adjusting, responding, and settling into repeating patterns that preserve its integrity. A frozen artifact of natural processes that predate biology. A laboratory shaped by the galaxy itself. A place where the earliest ingredients of life learn to arrange themselves long before anything breathes. Take another breath. Let that possibility float gently inside you. Another insight came from the way the internal vibrations anticipated the thermal pulse. This was not thought, not planning, not any kind of intention. It was simply the behavior of a system so deeply organized that one part responded to the subtle shifts in another, like the way tides rise before the sea becomes visible, or the way a tree shivers before a gust of wind arrives. Not foresight, just sensitivity. One scientist put it beautifully: it is not alive, but it is aware of its own structure. Not aware as a mind, but aware as matter. Matter that has lived in silence for longer than our species has existed. Take another breath. Long, deep, peaceful. The dust halo also carried a final lesson. When 3I Atlas was alive with heat, the dust gathered in resonant arcs, echoed the pulse and formed subtle ripples. But when the traveler cooled, the dust dispersed again, free, random, unorganized. It was a reminder that every system depends on energy. Without energy, patterns fade. Without warmth, rhythms quiet. Without the sun, the traveler returned to sleep. Not death, not ending, just sleep. The natural state of interstellar matter. Take another breath and notice how soothing that idea is. The blooming lines on the surface offered one last insight. As they froze, they preserved their final shapes, a snapshot of the traveler's brief awakening. Patterns that belonged to a moment in cosmic time, when a distant star stirred something ancient into motion. Those frozen motifs will remain for millions of years, perhaps until the traveler meets another star, another warmth, another moment of awakening. And perhaps one day, another civilization will see those patterns as we saw them, and they too will wonder. Take another breath. So easy, so light. In all of this, what stands out most is not that we found something alive. We did not. 3I Atlas is not a creature. It does not think. It does not feel. But we found something just as important. A system that blurs the boundary between the inert and the organized. A world that carries the architecture of possibility. A body that remembers and repeats its own patterns across millions of years. It showed us that life might not begin with cells or membranes or replication, but with rhythm, with cycles, with the delicate dance of matter, finding stability through time. Michio Kaku said it best in a quiet interview after months of studying the data. 3I Atlas is not alive, but it teaches us that the universe is full of matter, waiting for the right conditions to awaken. Take one last breath. Let it be long, soft, and grounding, because in the final part 20, we bring this journey to a peaceful close, reflecting on the traveler's gift and guiding the listener into rest. Let your breath fall into its final soft rhythm, slow, gentle, like a candle flame, settling after a long night, because now we arrive at the closing chapter of our journey with 3I Atlas, the ancient traveler that drifted into our solar system, awakened for a fleeting moment beneath our sun, and then continued quietly on its endless voyage into the stress, deep, tender, dark. As it faded into distance, its patterns dimmed, its flickers softened. The blooming lines on its frozen surface grew still crystallized, preserved in the cold memory of its passage. And yet in that brief moment of warmth, that cosmic blink, 3I Atlas left us with something profound. Not proof of life, not fear, not danger, but wonder. A reminder that the universe is full of matter that behaves in ways we have never imagined. Matter that organizes when touched by sunlight. Matter that holds rhythm when warmed by a star. Matter that can sleep for 1,000,000 years and awaken softly just because a warm glow passed near it. Take a slow breath and feel that wonder settle gently. As the traveler drifted outward, instruments followed it as far as they could. The dust halo continued to disperse each particle, returning to its solitary journey. The twisted light became straight again, pure reflection from a cold, silent shell. The internal pulses faded into lower, slower vibrations, still present, still ancient, but sinking into the traveler's familiar sleep. Scientists watched as the final thermal wave moved through the chambers, releasing the last warmth they had gathered from the Sunday. One by one, each chamber fell quiet, like lights turning off in a cathedral after a long ceremony. Michio Kaku said something gentle as the data faded. It is a world that remembers warmth, but is made to live in the dark. And so, the traveler continued outward, not lonely, not lost, just returning to the environment that shaped it, the soft silence between stars. Another breath, even slower now. The more scientists reflected on 3I Atlas, the more they realized that its gift was not in what it was, but in what it suggested. Its internal cycles hinted at the earliest forms of chemical organization. Its chambers hinted at proto-structures capable of carrying rhythm. Its dust halo hinted at systems that respond to energy and resonance. Its surface blooms hinted at patterns that emerge naturally when matter is given both time and a little sunlight. And all this quiet choreography formed without life, without DNA, without minds, without cells. Just the universe following its own language through matter. What 3I Atlas gave us was a glimpse into the space between geology and biology, between chaos and order, between silence and rhythm, between what is not alive and what may one day become alive under the right star, in the right light, in the right moment. Take another breath, a breath with no weight at all. Scientists believe that countless objects like 3I Atlas drift through the galaxy's silent archives of what matter becomes when time stretches into the unimaginable. Objects that carry ancient patterns in their core, waiting for warmth to reawaken them. Most will pass stars without stirring. Some may find warmth strong enough to bloom again. A few, very few, may carry structures that serve as the seeds of something more. But whether or not any such traveler ever bursts into life is not the message. The message is that life is not an anomaly. It is a continuum, a long progression of organization, beginning with things that look like three: I, atlas, rhythm, memory, structure, response, resonance. The earliest hints of the story that ends with beings like us looking up at the night sky and wondering what else might be out there. A soft breath. And so the traveler left us with a final understanding that the universe is filled not only with stars and planets and comets, but with potential, with matter waiting for music, with rhythms waiting for warmth, with silence waiting for sunlight to bring forth its quiet bloom. 3. I, Atlas, is now a small point of light, already fading into the black reach beyond our planetary neighborhood. Its chambers are cooling, its flickers are forgotten by the surface. Its dust is drifting away like tiny seeds scattered by the wind. But the memory of its awakening remains here, with us. And perhaps one day the traveler will warm again near another star, in another sky, before another species, who will look upon it with the same wonder. Take your final breath with it. Soft, steady, peaceful. Let your eyes grow heavier. Let your thoughts float free. And as we close this long, gentle journey, may you carry with you the quiet truth that even the coldest parts of the universe hold hidden rhythms and ancient stories waiting for the light. Thank you for traveling through this piece with me. If your eyes feel heavy, close them. Sleep well, stay curious, and see you next time. May the universe gently embrace you. As 3i Atlas drifts back into the quiet dark between the stars, I hope you can still feel the softness it left behind, that gentle reminder that even something ancient, silent, and cold can carry rhythms, patterns, and a kind of memory woven through millions of years of starlight. If you're still awake, thank you for staying with me until this final moment. Tonight we journeyed through dust and chambers, through blooming lines and flickers of forgotten warmth. And somehow, in that quiet, careful exploration, we found a deeper calm inside ourselves. And if you feel your breath slowing, your eyes growing heavier, just let them close. The universe will keep its stories safe until you return. Before we end, I want to thank you for being here with Fall Asleep to Science. If these peaceful journeys help you relax or bring a little quiet wonder to your night, I'd love for you to subscribe. It helps this channel continue exploring the calm, dreamy side of the cosmos with you, and I'd truly love to hear your thoughts too. What part of 3i Atlas stayed with you the most? The soft pulses, the blooming surface patterns, or the idea that something so ancient can still awaken under a warm sun? Share your reflections. Below, your voice always helps shape where our next journey will go. When you're ready to drift further, there are more gentle stories waiting for you on the screen at the end of this video. Each one a quiet doorway into sleep, curiosity, and the peaceful edge of the universe. Sleep well, stay curious, and I'll see you in the next night sky.